Okay, here's our Q&A for lecture number 3. Students were asking questions, but I've edited them out, and occasionally I will jump in here like this so that I can repeat the question that they asked, if I think that's helpful in understanding the response. The question was, what is a non-pure function aside from printing? Like, what might it do? For example, is changing a global variable non-pure function? There, the answer is yes. And if we're not supposed to do that, which I think we discussed last time in the Q&A, is that it's very rare for a program to involve changing global variables from within a function. What else might happen? Well, most of this is later in the course, but it turns out that a function can change not just a global variable, but something else. Like, for example, it could change another function, or it could change itself. Or there are things called objects, which we'll discuss in great detail, which are kind of a bundle of data and functionality together. And they have their own state. Like if an object represents a person, that person might have an age. And a function might change the age of the person that got passed into it. That would be an example of a change that's not just returning a value, and therefore the function would be non-pure. So yeah, so most non-pure functions are about kind of changing something in the program's memory, though often it's not a global variable. And then the other kind is that they're like doing something in the world, like printing something out or connecting to some other computer over the internet or something like that. The next question was about print. Is print a function that outputs none and displays whatever's in parentheses?
I wouldn't say that the output is none. It's the return value is none, right? So the output is usually what we refer to as what is being displayed on the screen when you print. So print displays whatever's inside the parentheses onto your screen, and it returns none to the calling function. And then let's
Okay,
call that.
so yeah, so I think the question is, if you have a function that in its body calls another function, what does the environment diagram look like? So let's take a look. Here we would, for example, call f on 2, and let's set the result to x. Oh, I used x already. How about w? So the def statements just create these functions and give them names in the global frame. Before we can assign anything to w, we have to call f in order to figure out what f of 2's value is. When we call f, we introduce a new frame in the environment diagram with its formal parameter x, or the name here x, bound to the argument value 2, which came from here. And then, oh, I forgot to return. Maybe I should have done that. I'm going to change my example, sorry. Here's where we were. Okay, so we're trying to assign y to something. That assignment will happen in the F1 frame because we're in the F1 frame when we're executing this line. But before we can make this assignment, we have to figure out what we're assigning y to. And that means calling g on x plus 1. So we look up what g is. There's no g here, so we look in the global frame. There's g. So we're going to call this function. What are we going to call it on? Well, we have to compute x plus 1, which is 2 plus 1 is 3. So here's what the diagram looks like, is that we have new current frame, where g is the function that we just called. Its formal parameter z, its argument is 3, and we execute its body. Z plus 3 is 6, so we get a return value for 6. And where we return to is wherever we were when we called g. So we're returning that 6 as the value of this expression, g of x plus 1. So now we can finish the y equals assignment statement where y is bound to 6. Now, why did it get bound here? This is the frame we were in when we were executing that assignment statement. We had finished with g's frame when we finished evaluating the right-hand side of this assignment statement. But we didn't finish the whole assignment statement until we actually bound y to something, which we did here. And then it's time to return from f. So we return 13. 13 is now the value of f of 2. We did all this work just to figure out what f of 2 was, and so we assign that to w. This was an assignment statement in the global frame, and so w gets bound to 13 in the global frame.
And notice, Anne, that when the F1 frame got created, it then created the F2 frame. The F1 frame was still active. right? Because we had to go call that thing and then compute something and then return it back to F1, at which point F2 is inactive. We're done with calling, the G function. And then the F frame is done, and then we're back to the global. So you can, at a time, there were two of those local frames were there, one for the F function, one for the G function. This is a great interface. So anytime something's unclear, it's great. Just throw some code in there and start stepping it through, and you can watch how the environments and the frames unfold. And what I like to do, by the way, is before you hit the next function, ask yourself, what do I expect to happen? Don't just click through and say, yeah, 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 yeah. Like, ask yourself, what do I expect to happen? And if it works, great. And if not, then there's a disconnect between your understanding and what's being evaluated. And that's the point at which we have to understand something, okay?
The next question was about prime factorization from lecture.
Good. John, do you have that code, or can you undo back your way through that?
Yeah, let me quickly type it out, and then we can talk about this particular thing that I did in the video, which
Wait, while John
doesn't surprise me that it caused lots of confusion, but go ahead.
I've never met somebody who can write code so goddamn fast and without mistakes. John, you should know that this is a superpower. This is John's superpower.
My superpower is actually that I edit out all the mistakes.
Damn it, John! You ruined the fiction.
Okay, so yeah, now we'll see if I edit this one as well. So we were trying to solve this problem in the lecture video, which was to print the prime factors of some integer n, which we described. There's an algorithm or an approach that I learned in school, maybe you learned it too, which is find the smallest prime number that divides evenly into n, then divide by that, and repeat that process, because you found one prime factor, but what you're left with after you divide by that, whatever it is, that k, is an integer that has all the other prime factors. So we wrote this down in the video. It looked something like, while n is greater than 1, find that smallest prime factor of n, divide by it, and now we have a new n to deal with, and then we're going to print it out. I think that's what it looked like. And this smallest, see, I make mistakes all the time, a smallest prime factor of n, well, it turns out that's just like the smallest number larger than 1 that divides evenly into n. So how did we do this in the video? I think it was something like, we start with k is 2, and while it's the case that dividing k into n does not give you a remainder of 0, then you have to try a different k. And if you start with k equals 2 and work your way up, then you get the smallest one that works, and you can return that. Okay. That passed the test, so it must have worked. Okay, so then what I did in the video is I said, wait, should I pause here for a second?
No.
Okay. What I said in the video is maybe we don't need smallest prime factor at all. Maybe we could just put this code in here. But it would have to be indented in the right way, right? So it might look something like that. And I showed this doesn't work because, well, instead of 2, 2, 3 for 12, it just showed you 2. In fact, if we do this interactively, it's easier to see. Prime factors of 12 is just 2. Well, that's wrong. You missed a 2 and a 3. Okay, so what goes wrong here is that this says keep going as long as n is greater than 1. Assign k equal 2. I mentioned in the video that this is already confusing because it's hard to tell what k is. And so it was better to have it broken out into 2 functions. But we're just analyzing what would happen if you tried to glue it all together into 1. Assign k equal 2. Keep incrementing k as long as it's the case that k does not evenly divide into n. That's what this expression says. So now k is going to get bigger and bigger and bigger until k evenly divides n. This line, return k, is a return statement for the function that you're in. And so since this is always going to get executed in the body of the while statement, this is always going to return just one number and never get to print anything out. As soon as you return from a function's body, you can't do anything else. Even if there's code down there, Python's interpreter never gets to it. So that's the problem with this version, is that the return statement here stops the iteration of the while statement because the first time through, the show's over. You return. Deleting this did fix the problem and left us with a working implementation that was hard to read, which is better than a working implementation, or which is better than a broken implementation, but not as good as an implementation where you could actually tell what was going on, which I think we had when we first wrote it down with two functions.
Right. So remember that return statement bound, as soon as you hit that, you are out of a function. Game over. And it was fine before because he was calling a function that was computing just that little result and then sending it back up to the original while loop. So when John just copied and pasted, you have to adjust that.
The question is, what's an intrinsic name and what's a bound name and what's the difference? Well, there's only one kind of important name, or a variable name as it's often called. And that's things that you can evaluate directly. So abs is a name that you can use. You can look up what it is. It's a built-in function. You can call it. If I assign abs to something else, now the name abs is still around. I just can't call it anymore because abs now means the number 7, and the number 7 isn't the kind of thing that you can call. Okay, so I'm going to quit Python and start over so that I can get my abs back. It turns out that you can assign other names to the same function. So now I have f, which is a name for the abs function. 2 different names for the same thing. It's something very natural, happens all the time in programming and in life. And that means that I can call it. Now here we have a mismatch between the name, or the bound name, if you will, and the function's intrinsic name, which is like the least important thing in the world, but it exists, and so I talk about it. A function's intrinsic name was the name that it had when it was created, and it is the name that gets displayed here when you kind of look at this thing and figure out what value it is. So if we move away from built-in functions and we come up with some like g of y is the simplest function, it just returns y plus 1. G is a name for this function. And this function also has an intrinsic name, g, which is kind of part of how it gets displayed. Now, if I set h to g, and I look up what h is, it's going to tell me not the function h, it's going to tell me the function g. Because this function hasn't changed. It still was g when it was created. Now it just has a different way to refer to it. And so I can call h of 12, and if I change g to something else, I could call h on g if I wanted. What's going on here is that h is the g function, and g is the number 7. And the g function, what did it do? It added 1 to things, and so we added 1 to the number 7, and we got the number 8. So here's the intrinsic name is g, which is the name of the function when it was created. And here's its actual name, the name that the interpreter is going to use to refer to it. And this is the important one, because all of your code uses the bound names.
John, can I ask you a question? Do you think it's a good idea that Python lets you redefine abs, max, and pi? Is this smart from a programming language perspective?
Yeah, good question. It's something you almost never want to do in a program that you build that like people are actually going to use. It is occasionally helpful when you're debugging or trying to hack something together. And you really wish, like, instead of printing, every time someone called print, I want it to like be sent to this website or something like that. Then you can go in and redefine print to do something else. And that can be a kind of a powerful way to glue stuff together that wasn't really designed to be glued together. The fact that it's possible is occasionally convenient, but it is really every programmer's responsibility to be very careful with this power and never use it unless they're just hacking stuff together. So
yeah, I'll mention you can sometimes do it inadvertently. So for example, it's very natural to call a variable max and then overwrite a built-in function. So you do sometimes have to be very careful. And by the way, that can create all kinds of problems downstream for you.
This is exactly right. So it's very possible this has done more harm than good over the life of Python. I think Python was designed not to build as large applications as it was built. Now Python was then redesigned. The Python 3 language is a little bit better at kind of keeping larger programs organized, I think. But still, yeah, it's a programming language that has features that you really shouldn't use very often.
Okay, good. Thank you.
Let's see. So I'm just going to jump back to this example. And if this example doesn't really tell you, well, actually, maybe I'll change it a little bit. So let's try that one. So G is a function that adds 3 to things. F's a function that adds 7 to 4 and ignores its input. Okay, both of them are weird, but let's just take a look at what happens. So we define F, we define G. The order here is interesting. Why did F come first? It seems like G should come first. Well, what happens first is actually that Python knows it's going to call G because it looks up the name G and knows it's going to call this function. But it can't call it until it knows what it's calling it on. And it doesn't know what it's calling it on until it's evaluated this expression inside, the operand expression called f of 2. And that happens to be another call expression of a user-defined function. And so we have to evaluate f of 2 before we can call G, because we can't build the frame for G unless we know what we're calling it on, unless we know the argument. OK, so f gets called on 2. X gets bound to 2, basically gets ignored. Y gets bound to 4. And that returns y plus 7 is 11. Now we know the value of f of 2, which means we can call G on 11. And that returns 14, which gets bound to W in the global frame. What's an environment? What's a frame? What's an environment diagram? This like whole picture is an environment diagram. The things that you can see are the frames, right? These kind of boxes. There's 3 of them. It turns out that each frame is part of an environment. In particular, each frame starts an environment. An environment is just a sequence of frames. This environment consists of F2, this frame, followed by the global frame. That's what this parent is. We'll talk about this a lot on Wednesday's lecture. And so there's actually 2 frames in this environment. There's the F2 frame and the global frame, which means that any code inside of G's body can refer to Z and can also refer to F or W or G, whatever's defined in the global frame. At the moment, W isn't defined yet, so if you refer to that, you get an error. But you could refer to F or G if you wanted to. So an environment is a sequence of frames, meaning more than one frame, but it always starts with something. It always starts with the current frame, and then it's followed by the global frame. You can get longer chains than this, but not yet, not until Wednesday's lecture.
So Ram, another way to think about this, if we had written W equals G of 1 plus 2, G can't be called until you evaluate that inner expression. You have to know what the value is going into because you're going to bind that to something. And so 1 plus 2 would have also created a frame, evaluated that, and then sent that value up. Yeah, so in some ways you have to sort of work your way. And by the way, we could have done it even more. We could have said G of F of H. You would have gone into the H, evaluated. That returns into the F, that evaluates, that returns into the G, and that eventually evaluates, yeah?
Good question. So this is like a very specific question, which is within the body of a function, like def f of x. Could you somehow have it be the case that there's an x that refers to the global x, and in some other line have an x refer to the local x? The answer is no. Within the body of a function, all uses of the same name always refer to the same place. Yeah, here, let me show you an example. All right, f takes no arguments. It has no names. We print x, and we want x to be some global thing. And then we want a local x, and then we want to print that. You might think, based on everything that you've heard so far, that when I call f, what f is going to do is it's going to look in the local frame, not find x, find the global x, and print out 2. And then it's going to set a local x to 3, and then it's going to print out 3. But that is not what happens. This violates the rule that within the body of a function, all the x's, all the same name, have to refer to the same frame. And so what will actually happen is that you'll get an error. When you try to print x, it will say local variable x referenced before assignment. And you might think, well, what is Python doing? I thought the rule was that if there's no x here, then look in the global frame. That generally is the rule, but this line 5 imposes a different rule. The different rule is that when you assign to x locally, then x is a local name, a local variable throughout the body of f. And so you can't have it be local and global at the same time. This is like a very specific detail, not something that we tend to test people on, but it does sometimes show up in people's programs that they write. And so you might as well learn about it. Within the body of a function, if you use the same name multiple times, it has to refer to the same frame. That's the only rule.
This is why, by the way, generally speaking, global variables suck. You generally want to send things into a function using parameters and send things out using return, so there isn't this sort of confusion of scope and where the variable is coming from.
Exactly. Life is fine if you just pass f in.
Right.
I mean, sorry, if you pass x in. Right. Then you print it out as 2, you change it to 3, you print it out as 3, and life is good.
Yeah. And don't get me wrong, the global variables are super convenient, which is why people use them. But really, it's not good coding style to have things, particularly as your code gets long and you can't keep track of variables. Yeah.
The next question was about the order of frames. They appear in a certain order in an environment diagram, but we've been talking about a different order, and that's confusing.
So we have f of x, we've got g of y. We call f of g of 7 or something like that. There's an order that appears on the screen. And here it's right. The global frame is always at the top. There's always one global frame. It always was there first. And that's why we draw it at the top. The order you see on the screen is just the order in which they were created. But that's different from the order that Python uses to look up the value bound to a name. And that second order, the order of the environment, is more important than the order that you see on the screen. That order tells you which x is found when there's 2 x's. So there's a slight change to this. Let's say I have x is 50 or 42 up here. The really important order that we care about is what is x? And in that order, the environment's order, we look first in the current frame and then in the global frame. So that's what we're talking about with the order, is like where do you look first and where do you look next? If we looked here first, then we'd get x is 42, but that's wrong. X is 9. So we look here first, find that x is 9, and we never look in the global frame for the value of x, and that's why this returns 10.
That's right. So as John said, the order that you're seeing them is the order they were created. But when you go to evaluate, you start in your frame and then you follow to the parent, right? So the order there is just a visualization. That's not how it's actually happening behind the scenes when you're actually evaluating the code.
Yeah, these orders represent different things. Like the order on the screen is the order in which stuff was called. Like that's important too. You got to know, what's happening when. But in terms of figuring out what names mean, which is the whole point of environments, it's just to tell you what names mean. Then, yeah, the order of the environment matters, just like Hani said. Yeah, that's exactly
what they're asking is if there's no return statement, how do you know when you're done with the function? Yeah. And the answer is yes, it's the indentation. Okay. Now, some programming languages have explicit, you have to end the function like with a curly bracket or with an end statement. But yeah. Python ends not just function definition, but while loops, conditionals, everything that is in the body of a conditional, John is writing this right now, or a while loop, or a function definition is determined by the indentation. By the way, personally, I don't like that. I prefer to have like an explicit begin end, but this is the Python syntax. John, you wanted to add something?
No, you just answered the question faster than it took me to write some example. So I just, like the body is just everything that's indented. So both the while and the if are in the body of this function f. But then when you get to the bottom, it returns none because there's no return statement and you're done.
Good. And John, somebody's asking about the difference between spaces versus indent.
Good question. So because Python cares about indentation, it also forces you to be consistent within a program how you indent. So for example, if I indented this with 3 spaces and I indented this with 4 spaces, then Python would get mad. It says unindent does not match outer indentation level. It's basically telling me like I'm not consistent in the way that I'm indenting. So you have to be consistent both in the distance that you indent and also how you indent. There's actually 2 different kinds of like multi-space blocks. There's a bunch of spaces in a row, and then there's also a tab. And this is just like a fact about how text is encoded in computers, that there's 2 different ways of encoding white space, either a tab or a bunch of spaces, and you have to be consistent. So usually what happens is that you configure your editor so that it never generates the tab. It only generates spaces, and then you use a consistent number of spaces. And every time you press the tab key, instead of inserting a tab character, it inserts 4 spaces, and then life is golden. Good question. So can there ever be more than one local frame in an environment? Yes. We don't know how to create that yet. I'll give you a preview because we're going to do it in lecture on Wednesday, which is that if you have a def statement within a def statement, you get this kind of configuration. Why you do that and how is something that I think we'll talk about in Wednesday's lecture, but it is possible. And there's a reason to do it, but we haven't really seen it yet. So everything we've seen so far only has the local frame and then the global frame. Okay, so I think to answer this, we have to go into here. So let's say we're just editing a file, and we write 12 in the file, and we run this file. Nothing gets displayed, right? The only time something interesting happens is when we actually print. So if I print this, then I can see what's going on. And in this sense, like, none is no different than 12. If you just have it, then nothing happens. But if you print it out, then you can see it. So within a file, none is basically like any other value. The place where none is special is in the interactive Python interpreter. If I type 12 here, I don't have to print it. It gets displayed. If I type none here, it doesn't get displayed. So you can see the difference, I think. What's going on is that there's just a rule, which is that this interactive Python interpreter evaluates whatever expression you have here and displays its value unless that value is none, in which case it doesn't display the value. None could be displayed. You could print it, but it won't be displayed automatically. So if I write a function that doesn't return, it just computes x plus 12. So now I have a function that computes 13 but doesn't return it. It returns none. I see no output. Why is that? Well, y is a value. It just happens to be the value none, which is that special value that doesn't get displayed automatically.
So just think of this as a special case of how dealing with none. It just has decided, it's just a rule, as John said. And it could have been otherwise, by the way. It could have been that you treat none like an expression and it displays it. It just doesn't.
The next question was, is a frame and an environment the same thing?
Good question. They're not the same thing, but there is a one-to-one correspondence between them. For every frame, there's an environment. For every environment, there's a first frame. So an environment is the sequence of frames that starts with a particular frame and also includes its parent. And if it has a parent, then you can get a whole chain of frames in an environment. Well, we'll see that happen later in the week, Wednesday and Friday. So frame and environment are not the same thing. But for every frame, there's an environment. And for every environment, there's a first frame. Yeah, good question. So how does Python tell that this is one statement and that somehow elif is related to this if as opposed to being its own thing? Which is really what's going on here, is like you can't just have an elif. it will tell you this is an invalid syntax. Elifs are only allowed to follow ifs directly. And the way Python's interpreter knows this is that it knows the rule for if, which is that if begins a statement, but that statement doesn't end until the kind of next unindented clause is not an elif or an else. So
the other
if
way
I
to think
wrote,
about this, James, is the statement is if. That's the statement. The elif and the else, by the way, are optional. So I can just write if x is greater than 0, done. So the core statement, the beginning of a conditional must always start with an if statement. You can have 0 or more elif clauses, and then 0 or 1 else clauses. So that's how Python knows. It has to start with an if clause, and then you have all these optional things underneath it.
yeah, that's exactly right. And if you stuck something else in there, like a def, which is, I think, part of your question, then in the interactive interpreter, Python says, well, that's not part of an if. So what are you doing? Inside of the block of code that you might write in a file, if you wrote if 1 is greater than 2, then print 1, and then you start defing something, that's fine. But this is not part of this statement because doesn't start with one of those two special keywords, elif or else. Instead, it's something else. And so Python just thinks of this as like, oh, here's some new statement.
John, I'm going to interject a question from the chat. Several people are asking about lab extensions and want to know when they will get the thumbs up or thumbs down.
Good question. So, I mean, if you fall into one of the categories that I put in my video, like you're in a European time zone, then you can expect a thumbs up, and we'll process them today. But you can assume that they're already processed. If you have some other reason why you need lab extensions, then I guess we'll try to get to those today, but I can't tell you exactly when.
The next question was, instead of floor division, can't you just round?
Yes, there is a round operator in Python. Do you want to show it to us, John?
Sure. So you're dividing
By the way,
4 by 3. What is 4 divided by 3? Well, it's 1.333. If you do floor division, then, oh, this is a terrible example. 5 divided by 3 is 1.666. If you do floor division, then you only get the 1 and the 0.666 is on. But shouldn't this round up? Well, the way you'd round up is you'd get the actual number, or at least an approximation to it, and round that.
Good. So by the way, just generally speaking, there's 3 ways to do quote unquote rounding. There's the floor operator, there's the ceiling operator, which means you always go up, and then there's the round operator, which toggles at the 0.5. Yeah. And all 3 of those there are Python functions for them.
Yeah. Okay, so the question is, what's going on with this example? You know, where am I and what's going on the page? Don't worry about that. Just know that this is something that shows up in your lab. And the lab example says positive equals -9, negative equals -12, while negative if positive. And the question was, how come this isn't like a comparison?
Right.
Like x equals 2 or something like that.
Right.
Mm-hmm.
Well, it turns out that every time you make a comparison, so x is greater than 2, this is an expression that has a value. And we could give this value a name. And this value, true, is something that could be used inside of a Boolean context. So that's like this first line in an if statement. And this is equivalent to having written if x is greater than 2, print 7. Right? We've just kind of done the work already of computing the value of x is greater than 2, given it a name, and then referred to that value by name instead of by the expression. Okay, so that's part of the story, is that it's okay to just like write a name here. And whether the value of this name is true or false will determine whether you go in here or not. The other part of the story, which is covered in the lab in some detail, is that not just true and false can go in here, but actually any value. So it turns out if you say if 12 print 7, Python will print 7. What a strange thing to say if 12. Well, it turns out that every number is either a true number or a false number, and this is just part of Python's definition. Some people hate this about the language. Some people like it. It just is what it is. So it's like a rule that you have to memorize.
I don't think you should do it. I don't like it.
Yeah, but it is done a lot in the world. So even if you don't do it, which I would encourage you not to do, like you'll see other people do it, so you might as well learn about it. It turns out that every number except for 0 is a positive value. So if I say if 0 prints 7, it's not going to print 7. Whereas, what have I done? Disaster. Well, it's not going to print 7 twice. Whereas if I say negative 12 print 7, then it will, because, you know, the creators of Python decided that negative 12 was a true value. Why is it a true value? Because it's not 0. So there's just like a quick way to check whether something is 0 or not, which is if you just like use it as a true or a false value, then everything that's not 0 will be true, and everything and 0 will be false.
Hey, John, what happens if you say if the string aardvark print 7?
Aardvark has 2 A's, right?
I think so. That wasn't a test, though, but
I don't know if I passed it. So this will print 7, because it turns out in Python, another part of the definition is that any string that's not empty is a true string.
Yeah. This, by the way, is why I don't like it, because that's a ridiculous statement.
Yeah. So it's one of these things where, you know, most of learning a program is about mastering the concepts, but some of it is about memorizing annoying details that someone else came up with. Python has some of these, not the fewest, not the most of programming languages, but you know, some of these things that you just have to memorize. And one of them is like what's false and what's true. And the basic story is that like empty things, like strings that have no contents, and 0 is kind of empty, are false, and other stuff is true. But there's a bunch of details behind that, and we'll mention it every time it comes up in the course. But that's what's going on with that if negative example. So if I set this to negative 12, and then I say if negative, or I guess it was is positive or whatever, then it is going to print just like this was going to print. Yes, I will do that. So the question is, if you have 2 ifs in a row, how is that different from having an if and an elif? I'm going to write this in a file. And this will be the last question that I answer, because I also have to go. But it seems like no one else is raising their hands, so this will work out perfectly. If you have 2 different ifs, let's get x equal to 2. If x is greater than 1, then print yes. Or how about go? If x is greater than 0, then print bears. These are 2 separate, unrelated statements. And so Python will execute the first one, and then it will execute the second one. And therefore, they both might execute. Oh, I forgot to save. So we get go bears. Elif is different because this is now one statement where at most one of the different suites can possibly get executed. So if it's the case that x is 1 is true, greater than 1 is true, it will print go and skip the elif statement without ever trying to evaluate its elif condition. And so we see, what happened? Just go and no bears. So the difference between if elif versus if is that if could actually execute both things, whereas if elif is stuck only executing at most one.